Hello, my name is Alexander Brown, along here with Travis Papp and Bailey James, and this is the flex sensor circuit. So the flex sensor circuit consists of two elements. The flexometer here, which essentially serves as a variable resistor or potentiometer, and the servo motor here, which provides the desired output. Now to give a brief description layout here, I'm going to start with the servo. You first have this blue wire or connector here, which essentially connects it to ground. You have this red wire here, which connects to the source voltage, which is 0 to 5 volts nominal, as provided by the USB connection. And you have this white cord here, which connects to actually the output from the Arduino program source code itself. With the potentiometer, or I should say the flexometer here, you have its one lead connection connected to, again, the source voltage here. And then as you can see from its other terminal here, you have it connected in series with a 10 kilo ohm resistor, which then goes to ground. However, you can also see this green wire here, which connects to the analog input. The analog input is perhaps the most important feature of the circuit because it, along with the source program code, provides a means of conversions wherein voltages are converted to a digital signal, which is then converted to a angular displacement degrees via a pulse width to the servo motor itself.
To make this experiment work, in the source code, the map function has the following syntax as shown. With 4 inputs, the from low, from high, to low, and to high. This programming functions resolves a scaling issue between the analog and digital signals. The original source code was default valued for the from low and from high were 50 and 300 respectively. This represents the analog input.
Using the serial monitor, the analog input values were taken at the unflexed position and flexed position, which was approximately 180 degrees, were observed to be at 287 and 297 respectively.
Thus, the values were inputted into the from low and from high entries, and the code was compiled and ran.
So here's a brief demonstration. As you can see, if I bend this approximately 90 degrees, the arm of the, or I should say the blade of the servo motor traces my motion approximately 90 degrees. Again, untracked, again unflexed the flexometer, it returns to its original position. Now if I go 180 degrees, you can see it approximately followed my motion 180 degrees. Again, returning up, 90, up, 180. Again, it's not quite 180. This is due to some source of error in the actual circuit design itself.
This is Bailey. As previously indicated, the analog input is looking for a 0 to 5 volt range, as you can see on the board here where the red cable is plugged into. Due to the input range indicated on the breadboard sheet being 0 to 4.826, we assume the converted signal may have caused the servo to not reach quite 180 degrees. Other sources could be the actual mechanical component of the servo not being able to reach the full 180 degree mark. Another cause for error was the pin connectors required as per the initial setup. We actually found it difficult to get the cables to connect properly there without having to actually wiggle them and move them around and push them in to get the servo to act properly. As you can see here, we've bypassed the pin connectors and actually plugged the cables directly into the servo itself.